Uh, Hello, everyone. Uh, I know it's a little bit late, uh, but hello. I'm Leon, and I work at Solar.io. And today's talk is going to be about Ambient Mesh. So, show of hands if anybody has heard about HTO. Any HTO users here? Okay, so that's great. Uh, so let's begin with what is HTO. So HTO is a service mesh, and in simple terms, it's like a grab car for your application. And initially, when the service mesh started out, it used to be like a sidecar for every application. So if you had like a AWS app running, it would have like a sidecar for that app inside your Kubernetes cluster, which is all good, but it also means like if you have 100 applications, you had 100 sidecars, which means that you would have more resource usage, more cost for the Kubernetes clusters, right? So to make that better, what happened or what we came up with was called ambient mesh. Okay, so ambient mesh, what it does is basically it's the same software, it's HTO, but rather than having a sidecar, we now have these three components. A Z tunnel, which is an L4 proxy. So anybody here knows what layer 4, layer 7 is, OSI model? Nobody? OSI model? Okay, that's okay. So layer 4 is something that is like on the network layer, wherein you cannot like read the headers of the packet that is coming through or something like that. And L7 is where you have everything. Like you can read the response, you can read the request, you can see what the request looks like, right? An H-bone is something called as an HTTP protocol that is specifically made for this connections. So it can multiplex connections. Basically, like you can have bidirectional communication using H-bone, and it's completely secure. So anybody goes to a website here and sees a lock sign. Do you know what the lock sign is? Nobody? Okay, tough crowd. But so basically the lock sign is like an SSL secure connection, right, to the website. So this is something similar, but between your applications. Basically, if I have to connect application A to application B, I would be able to do that by just sending a request. So your application doesn't need to have any SSL certificates. Your application doesn't need to know anything about anything in like when it's running in Kubernetes, right? So this is what a Z tunnel looks like. It can do TCP routing. It can do mutual TLS. That is TLS on both the ends. So basically, if I want to talk to maybe like two CIA agents talking, they have to have like a secure communication, right? Both the sides, it has to be secure. So MTLS is something like that, where you have security on both the sides. And the next thing is it can do authorization. So if I want to say application A should only talk to application B, it can do that, right? The next thing is it can do observability. So applications running in Kubernetes often require statistics, metrics, and all these things, right? So you can get a lot of TCP metrics from the Z tunnel that you can use in like Prometheus, you can use it in Grafana, something like that. The next component is the waypoint, and it is the L7 proxy. So you can do everything here that is layer 7, like HTTP routing, load balancing, circuit breaking, and rate limiting, and all these things. Security-wise, you can also do more authorization. Now you have the request, you can like see what the request looks like, and you can authorize the application based on that. Observability, you can get HTTP metrics now rather than just TCP metrics, and you can do access logging, tracing. All the observability fans know how much tracing is important these days. Yeah, so this is like a quick gist of like what is better like over sidecars. So because there is no sidecar per application, you now get things like reduced cost, more scalability because your applications don't need to restart every time you do an upgrade. And it's very transparent in the Kubernetes cluster. Like if I deploy Ambient Mesh, the application doesn't even know that the connection has changed. And I will show you all in the demo how that looks like. Yeah. So this is the ambient L4 architecture. So this is between two Kubernetes nodes, for example. There's like product page and reviews on one node, and ztunnel is a component that is the L4 proxy. By default, you don't need a waypoint. You can just use like ztunnel, and that can be used to secure your communication between applications. And your application doesn't even know that there's something called a ztunnel running in the cluster. This is all deployed by like a cluster administrator. And yeah, so between nodes, you will have like secure communication the moment you enable ambient mesh in Kubernetes using HTO basically. And this is the L4 plus L7 proxy. So you have the Z tunnel and the waypoint now. And between the applications, you will have all MTLS connections going via the Z tunnel between nodes. And between the applications, you can use a waypoint. That's like a layer 7. So this is like the complete setup of ambient mesh if you have a waypoint and a Z tunnel. And now we move to the demo. Just a second. Okay. Little bit of technical glitches today. But yeah, so this is basically a small demo. Uh, I'm just starting out by installing HTO in the mesh, and you can see the profile is set to ambient. So that means I'm using like the ambient profile here. And once it installs, nothing changes. Like nothing changes in the Kubernetes cluster once the installation is done. Yeah, and then I just install the gateway API CRDs. Okay. So yeah, at this point you have the ambient mesh and the gateway API CRDs installed inside the Kubernetes cluster. And there's also a book info application that will be running inside. Okay, it should be it. Yeah. So this is the book info application, and yeah, so now we deploy the book info application in the cluster, and we'll create these products, reviews, and ratings. So these are all different nodes, different microservices, and you can see the container is being created, and then we deploy like a HTO gateway inside the cluster. And you can see there's only HTO gateway, there is no sidecar. So you can see there's ready one by one. So that's just one pod in the cluster or in the for the application. And yeah, then we can just view the book info page quickly. So yeah, this is the book info page, and this is just loading transparently. It's like a separate application that is running inside the mesh. And this is where we sort of, oh, yeah, this is where we sort of start getting started with the ambient stuff. So right now, all these applications are just running normally, and we sort of add this label to it called HTO IO data plane mode ambient, and it's only applied to the Kubernetes namespace. So none of the applications have any idea of that. And once we do that, all the traffic starts getting encrypted between the application pods. The book info application is like a microservice. So everything that's on the page is a separate microservice, like the ratings, the reviews. So just in a minute, once I open the book info page, yeah. So all these things are separate microservices that are running. There's a book reviews. The reviews is a separate microservice. The details are a separate microservice. Yeah. And now we will be using something called as netshoot to sort of like debug like see the traffic in the cluster. And this will like just sort of sniff all the traffic that is going on in the cluster. And you can see once we reload the page, if you see the traffic, it's like all gibberish. Like you cannot understand what it is because it's all encrypted. And the application did not have to do anything. The application is basically still communicating in plain text HTTP on the network, but it is all encrypted between the nodes. And you can see this also with an observability tool called Kiali. And this should load in a second. Yeah, so we'll just do like a load test. And yeah, this is a lot, but so then you will see that there's a thing in Kiali that shows the traffic. Yeah, so now I'll just enable the animation for the traffic, the waypoint proxies, and also the security. So this will show you how the communication is between between the applications basically. A little bit of zoom, and you can see that the lock symbol is there. So this is the gateway that HTO creates through which the application, like your traffic is entering. And you also have these identities that are automatically created for each application. So these are like MTLS, and only this identity can connect with the other app. Unless the identity doesn't match, no traffic can go through. And the application doesn't have to do anything. Like there is no certificates that the application has to load within the application. There is nothing. It's all transparent to the application. And yeah, you can also do authorization. So I'll just show a quick demo of how the authorization policy looks like. And you can see here, you can see the service account thing here. This is basically a Kubernetes service account that you create for the applications. And you can sort of authorize it based on the application. So you can see here we only allow the app product page, the label, and the principle is like book info gateway. So only the gateway can connect to the product page basically. And we'll try to deploy something known as a sleep app. And if you notice, it couldn't connect. So you see it says command exited with code 56. This is basically a sleep application that is deployed inside Kubernetes, and we are trying to connect to the product page from the sleep application. Now the sleep application obviously has a different service account. So with that, it cannot connect anymore. And this is only L4. There is no L7 related authorization policies or anything as such. Only L4 is needed to do like basic MTLS and all these things. So yeah, and this is, so now we can also do it on the L7. So we use a waypoint for that. We've created a waypoint for the application, and we'll just program it quickly. And now we get a little bit more, I would say, more fun stuff. So you can now block it, or you can only allow get operations via the sleep application to the product page. So none of the post, delete, all these HTTP methods will not work. Only the get method will work. And in a minute, yeah, so you can see it's only set to the method get. And so if I try to run like a delete method, so there is a delete method, and it won't work. It will say RBAC access denied, so like a role-based access control. And none of this is like in the application or anything as such. It's just ambient mesh in the cluster doing this. Because like none of this is allowed. Like review service is also not allowed to call the product page. And only the only one that will work is the sleep pod that will have get method by default. Do I have an? Okay. So the last example, what I want to show is how you can manage traffic. So many developers try to do the blue-green deployments, right? Like where you shift, or like weight-based traffic, where you can shift the weight between two microservices, like a version 1, version 2, sort of like an A and B testing method. So you can do that also uh, with the ambient mesh. So here we are using like a reviews service, and the reviews V1 has a 90% traffic, and the reviews V2 has a 10% traffic. So in total, out of the 100%, V1 will have more, uh, like it will have more connections. Uh, I, I initially, it's so let it, like you can sort out the connections and just see. So let me just. Yeah, initially, I did not get that right, so I had to do like a sort on the command, and that should show you. So yeah, you can see there was like out of the n number of like 100 connections that we did, 178 went to reviews v1, and 22 connections were reviews v2, and this was done without any application related commands or anything as such. It's just Kubernetes CRs that you create for HTO, and because of that, it's very easy to put it in a CI pipeline or GitOps pipeline. So we also do like Argo. So if anybody uses Argo, then we integrate with Argo, and you can just deploy it like a normal Helm chart. And yeah. And yeah, this is it, I think, for the demo. So yeah, this is it for the demo. I'm Leon Nunes. I am a CNCF ambassador. I also am a Mumbai Force volunteer, and I have few hardware meetups in Mumbai. And I also work with a lot of telcos over the years, mainly in India. And if you want all the resources that was like shown in this slide, you can just scan this QR code, and it should take you to a GitHub link like this. And you can see all the different projects that we do. So we also do agent, we also do gateway stuff, and we do AI stuff. So in case you're, it's all open source projects. If you want to contribute, want to check them out, they are all in this one link here. Where is it gone? Yeah, this is the QR code. So you can just scan this. Yeah. Yeah, I'm done. Oh. Is this good? Let me try. Yeah, it should work. So yeah, thank you.
Thank you. I think we have about a few minutes for one or two questions. If anyone have question for, có ai có câu hỏi gì cho bạn ấy không ạ? Có khoảng thời gian cho 1 đến 2 câu hỏi. Please.
Oh.
Question. There's, wait a minute. There are question over there
okay,
first.
Who's going to do first?
Sorry.
You or me? Okay. Yes. So you said that Ambient is a sidecarless. It doesn't use a sidecar. So I want to see the detail of how, I think, the detail of the changes that you made to the mesh, the architecture, so that the mesh could still work without having to inject the sidecar.
Yeah.
I mean, yeah.
So I didn't get the question. Like,
Okay. I would like to see a more detailed architecture of your solution.
so can you click accept? The blue button. Thanks. So if you want a more detailed architecture,
Yes.
this is the multi-cluster one. But yeah, I did anticipate something like this, so I kept everything ready. But yeah, so if you want a more detailed application, sort of how it works, it's something like this. Basically, these are Kubernetes nodes, and this is your application. You have a CNI, the container networking interface. We do use HTO CNI to sort of do what HTO needs to be done on the node. And what happens is every node gets a Z tunnel. So this runs as a daemon set rather than a single application or like a sidecar for each application. You have a SPIFFE ID. So if anyone works with Spire, SPIFFE, identity workload attestation, you know about SPIFFE. And SPIFFE is like a identity given to each application.
Oh, yes. Okay.
So basically, after that, you have the waypoint proxy. But you do not technically need a waypoint proxy. You can run the entire mesh with the L4. Unless you need layer 7 capabilities, then you can use the waypoint proxy, which is an envoy proxy.
Oh, right.
So it does not attach itself to an application. You can run it like a shared proxy between applications, between namespaces. It can run however you or your team wants to run the application.
Oh, right. Thank you for your explanation.
Thank you.
We have one more question over there, right?
Hello. I have a question about how the ambient mesh are going to work with like a multi-cluster, maybe like around 100 cluster of Kubernetes, and that have microservice for like several like, and they interconnect with each other. So can that tunnel with ambient mesh work normally like the sidecar solution before?
Yes. So basically, we do have clients that use like around, I think the maximum we've seen is like 200 clusters or 300 separate Kubernetes clusters. These are not even like 600 nodes, they're like 600 clusters. So they used to run sidecars in the mesh, and now they're slowly moving to the ambient mesh because it reduces a lot of overhead cost. So with that, you also get a lot of less resource usage, less consumption of the CPU and the memory. So you can also save on resources as well as have more applications in the cluster, because Kubernetes has like a per cluster limit or per node limit of pods. Yeah.
I have one more like mini question. So like when, for example, I am using sidecar, the sidecar way, but then can the migration between the sidecar way to Z tunnel be
Yeah.
like
Yeah.
super easy, right?
So There are migration guides written by us. Like there, if you go to this, the website that is this one, yeah. So we've got, oh, it's too bright. But we've got a lot of documentation on how you can like use ambient mesh. We are also working on a migration guide from the sidecars to the waypoints because, sorry, sidecar to like ambient, because as of today, you can run both of them together. So what you can do is you can sort of migrate whichever application you need and run the sidecars till you require them. And then slowly you can migrate out to the ambient mesh because the sidecars sort of hook into the application. So if I have to remove the sidecar, I have to also restart the application. So you do like a full restart of everything. You remove the sidecars. You just label the namespace as ambient for the ambient mesh, and that's it. So your applications transparently then get MTLS.
Yeah, thank you, thank you. That is very clear. Thank you.
Any more questions? Oh, there's one.
Oh, hello. So I see Ambient it still works like the Cilium. So can you say for us the advantage of this solution has anything more than the Cilium?
So we do not like to like compete with the CNIs because each CNI is different. So for example, Cilium has a lot of eBPF monitoring. It has a lot of like transparent proxying that can be done. HTO runs over that. So it's not like you have to remove your Cilium CNI. We work with any CNI that Kubernetes supports. So up until last year, we had a set of CNIs that we could work with, but now any CNI works with ambient mesh basically. So you can still keep using Cilium for its benefits, and then you can also use the ambient mesh for the service mesh side of things.
So, but I work with Cilium for 2 years, and I think, and I see that Cilium can provide to me the service discovery with Harbor UE.
Yeah.
So
yeah.
I can see the detail the API for call this API A to API C. So I think when I deploy the Cilium, the performance and resource to the Cilium is more cheap, more than the Istio service mesh.
Yeah, so that so now with ambient mesh, the usage has gone quite a lot less because the Z tunnel is a Rust-based micro proxy, so there's not a lot of overhead once you deploy the Z tunnel basically. The waypoint is a little bit more, I would say, it's like an Envoy proxy, so it has a little bit more details, but the Z tunnel is a very small micro proxy, so there's not much overhead once you install HTO ambient mesh, at least now.
Before, our system has 1,300 pods running in our system. So we deploy Istio service mesh first, and we monitor this for the long time, and the performance of our system always more than 80%. So when we change to using Cilium, the performance is down.
Got it.
From another.
So yeah, it all depends. Like there are a lot of different things when you do the mesh, right? So for example, if you just install ambient mesh, pretty sure the performance would be like negligible. But if you want to run both Cilium and Istio, you can do that as of today. Like I don't usually go into the whole, service mesh A is better than service mesh B. It's very workload dependent. For example, Istio is more performant in like scaling up. So when you scale it to a lot of clusters and all, you will see a lot more benefits. But Cilium also has its own benefits with eBPF and all the tracing it provides and the Hubble UI that it has. But as of today, it cannot still do proper mutual TLS, which is what Istio does with using the Spiffy Spire ID. So I would always recommend using them together rather than replacing one over the other. But again, it's very workload dependent.
Okay, thank you so much.
Có ai có câu hỏi gì thêm không ạ? By the way, I think maybe you can explain like how you can use the Ambient Mesh above the Cilium. I mean, what is the use case you recommend to use the Cilium? And Isto above, then he can understand it better. I think so.
Yeah, so I have not fully tested this, but a lot of users kind of run Cilium as a CNI. And now Istio supports Ambient Mesh with any CNI. So you should be able to run Cilium CNI as well as Istio Ambient Mesh together. And it's sort of it's like a layered approach. So when you use the Cilium CNI, you get a lot of benefits on the network level. You can do things like eBPF tracing, eBPF monitoring, and it's all transparent, similar to Ambient Mesh. It's very transparent to the cluster. So your applications kind of don't know there's eBPF monitoring going on or something like that. And it's a very good project. It's also open source. I don't know if I can quickly put it on here. Let me try. Oh, not what I wanted. What happened? Oh, let's try again. Yeah. So I'm personally a big fan of the Cilium project. Like, it was like a very cool project, and it still is. So this is the Cilium website, and you can see that it sort of has a lot of use cases, mostly networking use cases, like the CNI. You can do layer 4 load balancing, cluster mesh. You can use it as an egress gateway, as a service mesh. It also supports gateway API, which is the up and coming API that replaces the ingress. So I would always suggest to use both together because the ambient mesh is like a quite less overhead now compared to before, where you had sidecars for each application. And yeah, so with Cilium, you can do a lot of cool things on the CNI level. So it's always like to use two projects together. So you have a lot more benefits from both the projects. So you can cherry pick which benefit you want, basically. I do not like doing the Cilium versus HTO sort of comparison because they both have their own strengths. So it's always like you can run the Cilium CNI as a CNI layer, and over that you can use HTO Ambient Mesh as a service mesh layer, basically. So you get a layered approach. You get defense in depth, sort of, because you have two different open source softwares now, rather than just a single point of like failure or single point software. But yeah, that is it. Is that what you were asking?
Yes, thank you. Thank you.
Thank you. Thank you.